The Planck Space Telescope is an instrument of extraordinary precision, launched by the European Space Agency in 2009 and operational until 2013. It mapped the cosmic microwave background radiation, the thermal afterglow of the Big Bang, with a resolution and sensitivity that no instrument before it had achieved. The cosmic microwave background is the oldest light in the universe. It was emitted approximately 380,000 years after the Big Bang, when the universe had cooled enough for electrons and protons to combine into neutral hydrogen atoms, allowing photons to travel freely for the first time. Before that moment, the universe was opaque. Photons could not travel freely because they were constantly scattered by the dense plasma of charged particles filling all of space. The cosmic microwave background is therefore not merely old light. It is the oldest light that physics permits us to see. It is the edge of the observable universe in time, the furthest back we can look using electromagnetic radiation of any wavelength. And the Planck telescope looked at it with an angular resolution of 5 arcminutes and a temperature sensitivity of 2 microkelvin. And what it showed us was a universe born from conditions of extraordinary smoothness and extraordinary heat, expanding from a state of near-infinite density, approximately 13.8 billion years ago. This is the data. This is what we know with confidence that borders on certainty. The universe began. It began at a specific moment. And before that moment, our physics produces nothing but silence and mathematical nonsense. This is where the terror begins. Because the question of what existed before the Big Bang is not merely a philosophical curiosity. It is a question with direct implications for the Fermi paradox, for the silence of the universe, for the absence of every civilization that should by all mathematical logic be filling the cosmos with signals we cannot miss. To understand why, you need to sit with the numbers for a moment and let them do what numbers do when you follow them honestly, which is make you uncomfortable. The universe is 13.8 billion years old. The Milky Way galaxy formed approximately 13.6 billion years ago. The first generation of stars formed within the first few hundred million years after the Big Bang. These stars were composed almost entirely of hydrogen and helium because heavier elements had not yet been synthesized. They lived fast, burned hot, and died in supernova that seeded the surrounding gas with carbon, oxygen, nitrogen, silicon, iron, and every other element heavier than helium. The second generation of stars formed from this enriched gas. Some of them had rocky planets. Some of those rocky planets were inhabitable zones. This happened billions of years before our solar system formed 4.6 billion years ago. The question the Fermi paradox asks is simple and has never received a satisfying answer. In all that time, across all those billions of years of star formation and planet formation and the availability of every chemical ingredient required for life, where is everyone? The numbers say there should be civilizations billions of years older than ours. The universe says nothing, and the question of what existed before the Big Bang is directly connected to why. The first theory of what existed before the Big Bang is the no-boundary proposal, developed by Stephen Hawking and James Hartle in 1983. The mathematics of this proposal are formidable, involving a path-integral formulation of quantum gravity in which the universe is described as a four-dimensional geometric object with no boundary in time. In ordinary spacetime, time is a dimension that extends infinitely in both directions from any given point. But in the Hartle-Hawking no-boundary proposal, the time dimension near the Big Bang becomes increasingly similar to a spatial dimension. The singularity at the beginning of time is replaced by a smooth geometric surface with no edge, the way the surface of a sphere has no edge despite being finite. In this framework, asking what existed before the Big Bang is like asking what is south of the South Pole. The question contains a hidden assumption that time extends before the Big Bang, which the mathematics shows to be incorrect. There is no before. Time itself begins at the Big Bang. The universe is a self-contained geometric object that simply exists, with no prior cause, no preceding state, and no external context. The implications of this for the Fermi paradox are chilling in their specificity. If the no-boundary proposal is correct, then every universe that exists is self-contained. There is no reservoir of prior universes from which intelligence could accumulate across cosmological timescales. Every civilization begins fresh, with a fixed amount of time available before the heat death of its universe. and no inheritance from anything that came before. The silence of the cosmos in the no-boundary framework is a silence of radical isolation. Every civilization is alone not merely in space but in time. The second theory is eternal inflation. Alan Guth proposed cosmic inflation in 1980 to solve several problems with the standard Big Bang model, including the flatness problem and the horizon problem. Inflation proposes that the very early universe underwent a period of exponential expansion driven by a quantum field called the inflaton, expanding by a factor of at least 10 to the power of 26 in approximately 10 to the power of negative 32 seconds. The inflationary expansion smoothed out the initial conditions of the universe, explaining why the cosmic microwave background is so extraordinarily uniform. But inflation, once started, is difficult to stop everywhere simultaneously. In most models of inflation, quantum fluctuations in the inflaton field cause inflation to end in some regions while continuing in others. The regions where inflation ends become bubble universes like our own. The regions where inflation continues keep expanding, producing more bubbles, more universes, endlessly. This process, called eternal inflation, has no beginning and no end in the framework of the theory. The inflating background spacetime is eternal in both directions of time. Our universe is one bubble among an infinite or near infinite number of bubbles, each with potentially different physical constants, different particle masses, different force strengths. The data from the Planck telescope cannot directly confirm eternal inflation, but the inflationary model it strongly supports is the theoretical framework from which eternal inflation naturally emerges. In the eternal inflation framework, the Fermi paradox acquires a new and deeply unsettling dimension. If our universe is one bubble among an uncountable number, then the silence we observe within our bubble tells us nothing about what exists in other bubbles. There could be civilizations of unimaginable advancement in adjacent bubbles, separated from us by bubble walls moving at the speed of light, forever unreachable and forever invisible. The silence is not a silence of absence. It is a silence of perfect separation. We are alone in our bubble, surrounded by an ocean of other bubbles we will never access, each potentially teeming with life and intelligence and history that we will never know existed. The third theory is the cyclic model, developed by Paul Steinhardt and Neil Turok in the early 2000s as an alternative to inflationary cosmology. The cyclic model proposes that our universe is a three-dimensional membrane, called a brane, existing in a higher dimensional space called the bulk. A second brane exists parallel to ours in the bulk, separated by a small extra dimension. The two branes are attracted to each other by a potential that causes them to periodically collide. Each collision is experienced as a big bang from the perspective of observers on either brane. The collision dumps enormous energy into each brane, creating the hot, dense initial conditions of a new cosmological cycle. Each cycle lasts approximately 1 trillion years and ends when the branes collide again, beginning a new cycle. In this model, there is no beginning and no end. The universe has been cycling through big bangs for an infinite or near infinite number of cycles. The data from the Planck telescope places constraints on the cyclic model, particularly regarding the predicted spectrum of gravitational waves from the Big Bang, which the cyclic model predicts to be below the detection threshold of current instruments, while inflation predicts a specific spectrum that future gravitational wave detectors may be able to measure. The cyclic model's implications for the Fermi paradox are perhaps the most disturbing of all the theories. If the universe has been cycling for an infinite number of cycles, then civilizations have had an infinite amount of time to develop and expand. An infinite number of cycles with finite probabilities of civilization emergence in each cycle implies that civilizations should have arisen, expanded, survived somehow across the bounce, and filled the cosmos beyond any reasonable definition of thoroughness. The silence in a cyclic universe is not merely strange. It is mathematically incomprehensible. It implies that something has been resetting the cosmic ledger with every bounce, erasing every civilization that arose in the previous cycle, preventing any inheritance of information or structure across the bounce boundary. Whatever that mechanism is, it has operated with perfect efficiency across an infinite number of cycles, and it shows no signs of making an exception for us. The fourth theory is the quantum tunneling from nothing proposal, associated with the work of Alexander Vilenkin in the 1980s. Vilenkin proposed that the universe could have emerged from a state of absolute nothingness. Not empty space, not a quantum vacuum with virtual particles, but genuine mathematical nothing, through a process analogous to quantum tunneling. In quantum mechanics, particles can tunnel through energy barriers that classical physics would prohibit them from crossing. Vilenkin applied this principle cosmologically, proposing that a universe with zero total energy could quantum tunnel into existence from a state with no space, no time, and no matter. The mathematics of this proposal involve the wave function of the universe, a quantum mechanical description of the entire cosmos treated as a single quantum system. The numbers in Vilenkin's framework predict a specific probability distribution for the initial conditions of universes created by quantum tunneling, favoring universes with the minimum possible initial size and the maximum possible rate of subsequent inflation. The framework also implies that quantum tunneling from nothing is not a one-time event, but an ongoing process. New universes are constantly tunneling into existence from the quantum nothing, each one a fresh start with no connection to any other universe. In Vilenkin's framework, the Fermi paradox is addressed by radical isolation of a different kind. Every universe that tunnels into existence begins fresh, with no inheritance from any other universe. There is no mechanism by which intelligence from one universe could influence or communicate with any other. The silence we observe is the silence of complete cosmological independence. We cannot hear anyone else because there is literally no medium through which signals could propagate between independently tunneled universes. We are not merely alone in our galaxy or our universe. We are alone in a way that no expansion of our technology could ever overcome. The fifth theory is the string theory landscape, which emerges from the mathematics of string theory and the concept of the multiverse it implies. String theory is a theoretical framework that proposes the fundamental constituents of matter are not point particles but one-dimensional vibrating strings. The theory requires the existence of additional spatial dimensions beyond the three we observe, typically 6 or 7 extra dimensions compactified at scales far below anything current experiments can probe. The specific way these extra dimensions are compactified determines the effective physical laws in the resulting four-dimensional universe. String theory calculations suggest that the number of possible compactification geometries is approximately 10 to the power of 500, each giving rise to a universe with different physical constants, different particle masses, and different force strengths. This enormous collection of possible universes is called the string theory landscape. The anthropic principle, combined with the landscape, suggests that we observe the physical constants we do simply because they are compatible with our existence. Most configurations in the landscape are incompatible with the formation of atoms, stars, planets, or life. We find ourselves in a configuration that permits life because we could not exist in any other. The Planck telescope data cannot directly confirm or refute the string theory landscape, but the measured value of the cosmological constant, which is inexplicably small in a way that requires either enormous fine-tuning or a selection effect from a large ensemble of possible values, is consistent with the landscape framework and deeply inconsistent with any framework in which our universe's constants were determined by a unique physical mechanism. In the string landscape, the Fermi paradox acquires a statistical dimension. With 10 to the 500 possible universe types and only a tiny fraction of them capable of supporting life, the universes that do support life are so different from each other that intelligence in one has essentially nothing in common with intelligence in another. The silence is not a silence of absence, but a silence of radical difference. We cannot recognize signals from other civilizations because they evolved under physical laws so different from ours that their signatures, if any exist, are invisible to instruments designed around our own physics. The sixth theory is the black hole cosmology proposal, associated most prominently with the work of Lee Smolin on cosmological natural selection. Smolin proposed in the 1990s that new universes are created inside black holes, and that the physical constants of the child universe are similar but not identical to the parent universe, with small random mutations. Universes that produce more black holes produce more offspring universes. Over cosmological timescales, natural selection drives the distribution of universes toward those with physical constants that maximize black hole production. The constants in our universe are in fact well suited to producing stars massive enough to collapse into black holes, and the number of black holes in our universe is enormous, suggesting that our universe is a reasonably fit member of the cosmological population in Smolens's framework. The data from the Planck telescope provides indirect support for this model by confirming that the universe's constants do support abundant star formation and therefore abundant black hole formation. In Smolens's framework, the Fermi paradox becomes a question about the interior structure of black holes and what, if anything, survives the formation of a child universe. If information from the parent universe is inherited by the child universe, then civilizations that learn to create black holes might, in principle, seed child universes with information. The silence we observe might be the silence of a universe that has not yet produced civilizations capable of this technology, or a universe in which civilizations consistently fail to reach this capability before their own extinction. The seventh theory is the most speculative and perhaps the most psychologically difficult to sit with. It is the simulation hypothesis applied at the cosmological level, the proposal that what existed before the Big Bang is a computational substrate. A system running our universe as a simulation for purposes we cannot determine and may not be capable of understanding even if they were explained to us. The numbers here are not physical measurements, but logical arguments. Nick Bostrom's simulation argument establishes that if any civilization in any universe has ever developed the computational capacity to run detailed simulations of conscious minds, and if they have run more than a trivial number of such simulations, then simulated minds vastly outnumber biological minds, and a randomly selected conscious entity is almost certainly simulated. The Planck telescope data, which shows a universe with a resolution limit at the Planck scale and a maximum information density consistent with the holographic principle, is not inconsistent with a simulated universe. A simulated universe would have a resolution limit determined by the computational resources available to whatever is running it. The holographic principle, which states that the information content of a region of space is proportional to its surface area rather than its volume, is precisely what you would expect from a universe rendered from a two-dimensional informational substrate. Before the Big Bang, in this framework, was the initialization of the simulation, the moment at which the parameters were set, the random seed was chosen, and the program began to run. The silence of the Fermi paradox in this framework is the most unsettling of all seven theories, because it implies that the silence is not a physical fact about the universe, but a design choice made by whoever or whatever is running it. Other civilizations may exist in the simulation, and their silence may be enforced, not by physics, but by policy. We may be in a region of the simulation that was initialized without detectable neighbors for reasons we cannot access. And the question of what existed before the Big Bang has an answer in this framework that is both simple and annihilating. Before the Big Bang, there was a programmer, and we are what the program is for, and we will never know why. And the universe will continue expanding and cooling and eventually end, and whatever conclusion the program was designed to reach will be reached or not reached, and then the simulation will terminate, and the question of what comes after will be answered in a context so far outside our capacity to conceive that the word after may not apply, and the only honest thing that can be said about any of it is that we are here, and we are thinking about it, and the thinking itself may be the only part of any of this that matters to whatever set it all in motion, and even that may not be true.